So Unit 3 is all about factoring. 3.1 is factoring using the 3 basic methods that you actually learned in Algebra 1. First method is GCF. First of all, who can tell me what GCF stands for? Thank you, greatest common factor. Second method is difference of 2 squares. And then the third method is trinomials with nothing in front of the x squared. Trinomials is the same as diamond method, or some of you called it like the X or the cross. I called it diamond, but that method, and you'll see when we get there. So let's look at example 1. Example 1, 3a minus 36. What do you guys notice about example 1, 3a minus 36? There's no equal because we're just factoring, you're not solving. Does 3a minus 36, those two terms, do they have anything in common? They both have 3's, right? That is the GCF. So you're going to factor using GCF method. Oh my gosh, if I can write a G. GCF. So the GCF here is 3. So how do we factor using GCF? First thing you're going to do is pull out the 3. And factoring is the same as dividing. So we're going to divide each term by that GCF, which is 3. So what's 3a divided by 3? A minus what? 12. 36 divided by 3 is 12. Now that we've broken it up, what does it look like? Distributive property, right? If we were to distribute the 3 back in, we would end up with what we started with. Okay, so what we're doing when we're factoring is we're breaking down an expression to all its little individual parts. Okay, so factoring out a GCF is one way that you can do that. As we go through our factoring methods, we're going to eventually learn 6 or 7 methods. GCF is the one you always want to check first. So I want you to write that note right underneath it. Always check for GCF first. Okay, so you want to always check that there's a GCF first. We'll make the G a lowercase. Okay. If there's a GCF and you start factoring before you take it out, you will not be factored completely. So you always want to check for a GCF first. Okay. Example 2, x squared minus 21. This is difference of 2 squares. I abbreviate it to diff of 2, and then I draw a square. Diff of 2 squares, okay? So difference of 2 squares. Let's break down what that means. Why do you think this method is called the difference of 2 squares? You can take the square root of both of these. X squared is a perfect square. 121 is a perfect square. And what is being done to them? Subtraction. What's another word for subtraction? Difference. So a difference of 2 squares means that you are taking 2 perfect squares and subtracting them. So how do we factor using this method? There is a formula for it, or a process. So you're going to set up 2 sets of parentheses. Inside one of them, you are going to put an addition in the middle. Inside the other, you're going to put a subtraction. Are the light bulbs coming on, guys? Do you all remember this? This is from like 8th grade, maybe 7th. Okay, so now I have 2 blanks inside of each parentheses. How do I fill in the blanks? What is the first term that's in my problem? X. So x squared, right? So what is the square root of x squared? X. So in the first blank of each parentheses, you're going to put the square root of the first term. So in this case, it's x. So then what would I put in the second blank? 11. 11 is the square root of 121. So we have factored using difference of 2 squares, x plus 11 times x minus 11. How could I check that this is correct? What type of problem does this look like? FOIL. Factoring is the opposite of FOIL. So if I were to do FOIL all the way through, and I'll do it really quick, x times x gives me x squared. X times negative 11 is negative 11x. 11 times x is plus 11x. And 11 times negative 11 is negative 121. If I were to do FOIL and then I combine like terms, look at what I end up with. What we started with. As soon as it comes up. Okay, so the 11x and the negative 11x cancel each other out. So we end up with where we started. So FOILing is the opposite of factoring. In this problem, we want to factor, so we're breaking it apart. But the black part right here is how you would check your work. Okay? So FOILing is the opposite of factoring. So to check that your factoring is correct, you can FOIL, and you should end up with what you started with. Looking at example 3, what did I tell you the first thing you should always check for is? A GCF. Is there a GCF in there? Yeah, what is it? A. So pull out the A. And then that leaves us with x squared minus 2x minus 15. Does this one look familiar? X squared minus 2x minus 15. It looks familiar. This is called a trinomial. So first we use GCF. Why would it be called a trinomial? There's 3 terms. Trinomial. How do you factor a trinomial? We're going to use the diamond method. So, diamond method, you're going to draw an X off to the side. The very last number goes in top, so it's going to be negative 15 on top. And the middle term, or the middle coefficient, goes on bottom, so we're going to have negative 2 on bottom. Now we are looking for the 2 numbers that multiply to negative 15 and add up to negative 2. What 2 numbers multiply to negative 15 and add up to negative 2? Negative 3 and negative 5 and positive 3. Okay. Good. So how do we use this? First of all, you bring your GCF down. The GCF never goes away, okay? So make sure that you continue to write it every single time. If you just magically take away the GCF, you've altered the problem and changed the value. Okay, so never, never, never take the GCF away. So then you're going to set up 2 sets of parentheses just like before. First term here is going to be x and x because we had an x squared as the very first term. And then you plug in those numbers from the diamond method. So plus 3 minus 5. The order in which you write the plus 3 minus 5 does not matter. So if you flip-flopped the 2 binomials, it would still be the same answer. Okay? So this is the same as a times x minus 5 times x plus 3. The order of those 2 does not matter. Okay? So far so good? You guys remembering this? Okay, so let's look at example 4. First thing I should always check for is a what? GCF. Is there one? Factor it out right now, please. All right, guys, what did you get as the GCF? 2. Okay, so when we factored out the 2, that left me with 9x squared minus 4y squared. Perfect. So we did a GCF first, so I'm going to write that off to the side. Can I continue factoring? Yeah, what method do you see now? Difference of 2 squares. Good. So this is a diff of 2 squares. So bring the 2 down and set up your difference of 2 squares. One is plus, one is minus. What I want you guys to try right now is fill in the blanks. Okay, guys, what is the square root of 9x squared? 3x. So you're going to put 3x in the first blank. Now, one thing I want you all to be aware of is because the x's come first here, the x's come first in your answer, okay? Sometimes these might be flip-flopped. Whichever comes first in the problem must come first in your factoring, okay? You can't just flip-flop those. And then what's the square root of 4y squared? 2y. And we are factored all of the way, so that is your answer. Example 5, we have y squared minus xy minus 6x squared. How is this one different than what we did before? It has a y squared and an x squared. That is going to affect our factoring, but it's not going to really affect the way that we apply the trinomial or diamond method. So what I want you guys to first is set up your two sets of parentheses. Okay, now which term is first, the x squared or the y squared? The y squared. So when we break that down, it's going to be y's in front, right? Okay. Now which term is last? X squared, right? So let's not worry about the numbers right now. Let's just worry about the variables. So with that x squared, we're going to break that down into an x and an x in the back. Okay? Because when we FOIL it out, when we multiply the y times the y, that's how we get y squared. And then when we multiply the back, the last terms, x times x, because that's our x squared. So now let's worry about the numbers. So let's apply the diamond method. What number goes on top? -6. Now there's nothing in front of the xy, but there is the invisible 1. So what term goes on bottom? -1. Make sure you attach the sign. Find me the two numbers that multiply to -6 and add up to -1. Multiply to -6, add up to -1. What did you get? 2, -3. Okay, so how do we apply this? You're going to put the +2 behind the y and the -3 behind the other. So when this is all factored, we get y plus 2x times y minus 3x. What I want you all to do right now is FOIL. How many of you used FOIL? Can I see your hands? How many used the box method instead? Okay, whichever one you're comfortable with, I want you to take what we just did, y plus 2x and y minus 3x, use FOIL or box method to check our answer. Okay, so because I used FOIL in example 1, I'm going to use box here. So we're going to do y plus 2x across the top and y minus 3x down the side. When I multiply y times y, what do I get? Y squared. Y times 2x, what does that give me? 2xy, good. -3x times y. -3xy. And -3x times positive 2x. -6. You guys see where the x squared comes from now? So when I combine my like terms, that leaves me with y squared minus xy minus 6x. Is that what we started with? Yes. So we did factor correctly, okay? So when you have a y squared and an x squared, you have to have your y's in one part and your x's in the other, depending on the order. But if you FOIL it all out or use the box method, you should still end up with what you started with. So that 6x squared, or that -6x squared at the end, comes from multiplying 2x and -3x. So it is not a mistake that both of these are x's. We have to put them there so that when we do this multiplying here, we get the -6x squared. Okay? So you can always check your factoring by distributive property, FOIL, box method, pretty much just putting it back together. So remember, factoring takes it apart, FOILing puts it back together. Okay? Example 6, 8x squared minus 32. What is the first thing you should always check for? Is there one? Yes. Take it out, please. Okay, ladies and gentlemen, what was the GCF? 8. So when I took out the 8, let me write GCF here. That gave me x squared minus 4. Done, or can I do something else? What else can I do? Difference of two squares. So do difference of two squares right now. Make sure you bring down the GCF. Okay, what goes in the first blank, guys? X's, and then what goes in the second? 2's. So we have 8 times x plus 2 and 8 times x minus 2. We are factored all the way. Okay, example 7. We have 4x to the 4th minus 4y to the 4th. What should I do first? GCF. What is the GCF, guys? 4. So take out the 4. So that's going to give me 4x to the 4th. Oops, minus, no. Forget this. Okay, 4 times x to the 4th minus y to the 4th. There we go. Okay, can I do anything else or am I done? There's a difference of two squares, right? So let's bring down the GCF and set up a difference of two squares. Okay, guys, what is the square root of x to the 4th? X squared. So put x squared there. What is the square root of y to the 4th? Y squared. I say we're not done. Why? There's still another difference of squares. Is x squared minus y squared a difference of two squares? How many say yes? How many say no? You guys, what does difference mean? Subtraction. Are those being subtracted? X squared plus y squared are being subtracted? It's the other one, right? So this x squared plus y squared stays the same, but this guy right here, x squared minus y squared, can be factored using difference of two squares. So bring down the ones that did not change. And then set up a difference of two squares for that second x squared minus y squared. What is the square root of x squared? X. What is the square root of y squared? Y. Now am I done? Yes. Adding two perfect squares cannot be factored anymore. So x squared plus y squared is as factored as you can get. Okay? So sometimes you will have to use more than one method to factor something completely. Okay? Last one, number 8. 3x squared minus 75. I want you guys to try this on your own. So try doing the entire problem the whole way through by yourself. Is there a GCF, guys? Yes. What is it? 3. So this is 3 times x squared minus 25. And then I saw that a lot of you did what? Difference of two squares. So bring the 3 down. And we set up our difference of two squares. I'm going to do this a little bit differently. How do I fill out this whole first set of parentheses? X plus 5. Good. And then how's the other one? X minus 5. Raise your hand if you got that correct. Oh my gosh. Air high fives to all of you. Good job. Okay, and that's it. That's factoring. Or at least a review of what we did in Algebra 1.